Hey guys, Dean Chase here with another geometry lesson for you. Hope everybody's doing good. Let's go ahead and get this started with a word of prayer. Dear Heavenly Father, thank you for today, give us, Lord. Thank you for all you do. Bless my students. Help us all have a good day and help us learn geometry. In Jesus' name I pray, amen. Alright you guys, so today we're going to be learning how to apply the triangle sum properties. This is lesson 4.1, page 217 if you're following out of the book I teach out of. So let's go ahead and get going. A triangle is a polygon with three sides. A triangle with vertices ABC is called triangle ABC, or you could just draw a triangle ABC. So, key concepts for your notebook today. We're going to be learning how to classify triangles by sides and classify triangles by their angles. So first off, by their sides, you can have a scalene triangle where all the sides have different lengths. You can have an isosceles triangle where at least two of the sides are congruent or the same, or an equilateral triangle where all three sides are congruent. Next, we'll classify them by their angles. You can have an acute triangle where all three angles are acute angles. The way I like to remember that is acute, tiny, you know. A right triangle will have one right angle. An obtuse triangle has one obtuse angle, so one angle that's going to be over 90 degrees, and then two angles that are going to be acute. That's an obtuse triangle. Equiangular triangle means it has three congruent angles. Okay? Let's go ahead and get started. So they want us to classify the triangle in the gauge shown in the diagram by its sides and by its angles. So, if we look at its sides first, we see that one side is 3 inches, one side is 4 inches, and one side is 5 inches. So none of the sides are the same. So we could say that this is a scalene triangle, right? Now, if we look at its angles, we see that this has one right angle. So we know that this is going to be a right triangle, okay? So this is a scalene right triangle. Let's keep going. Example 2. Classify triangle ABC by its sides and by its angles. So, to classify it by its sides, we're going to need to know all the side lengths, okay? And we're going to find that by using the distance formula. So the first thing I want to do is let's go ahead and label these points. So this is -5, 4. B is going to be 2, 6. And C is going to be 4, -1. Okay? And now all we have to do is plug these points into the distance formula, which we already know how to use. So, let's go ahead and find AB. AB is going to equal the square root of 2 minus 5 squared plus 6 minus 4 squared, which is going to come out to be the square root of 53. And I'm just going to leave it there. You could take it to where it's just a square root number, because you'll be able to tell if the square roots are the same. You'd have isosceles or equilateral, or if none of the sides are the same, you might have a scalene triangle. So AB is equal to the square root of 53. Let's go ahead and find BC. BC equals the square root of 2 minus 4 squared plus 6 minus 1. 6 minus 1 squared. And that's actually going to equal the square root of 53 also. So, we know it's at least an isosceles triangle. Let's go ahead and keep going and see if it's an equilateral triangle. Let's see if AC is going to equal that. So, AC is going to equal square root of -5 minus 4 squared plus 4 minus minus 1. 4 minus minus 1 squared. Okay? And that's going to actually equal the square root of 106. Okay? So we know that this is at least an isosceles triangle. I'm going to go ahead and write that down here. Isosceles triangle. Okay? Now we need to classify it by its angles. It's pretty visible that these two angles are acute angles. So either B is going to be obtuse, right, or acute. So one thing we could do to check to see whether it's a right angle is compare the slope of AB and the slope of BC. So the slope of AB is going to be up 1, 2, and over 1, 2, 3, 4, 5, 6, 7. So AB slope, I'm going to write AB's slope is 2 over 7. So let's check out BC's slope. BC's slope. BC's slope is going to equal, from B to C, we'll go down 1, 2, 3, 4, 5, 6, 7 over 2. So it's going to be negative 7 over 2. So those are opposite reciprocals, right? So we know if it's an opposite reciprocal, that is going to be a right angle. So it's a right isosceles triangle. I hope that made sense. Feel free to work this out completely by hand. I just didn't want to take the time. We do this almost every lesson. So just trying to save you time, save me time, and let's keep going. So, angles. When the sides of a polygon are extended, other angles are formed. The other angles are the interior angles. The original angles are the interior angles. The angles that form linear pairs with the interior angles are called the exterior angles. Okay, so you have the interior angles here, and then the exterior angles are the angles that are formed by extending the lines. Okay? So triangle sum theorem. The sum of the measure of the interior angles of a triangle is 180 degrees. And that's for all triangles that we are studying. So the measure of angle A plus the measure of angle B plus the measure of angle C will always add up to equal 180 degrees. Okay? Sometimes you have to draw auxiliary lines. To prove certain theorems, you may need to add a line, a segment, or a ray to a given diagram. An auxiliary line is used in the proof of the triangle sum theorem. And the triangle sum theorem I have right here. Feel free to pause the video and read through it. I'm not actually going to read through it with you because my voice, your inner voice, all does the same thing. So this is the proof of why the triangle sum theorem is true. So, theorem 4.2, exterior angles theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay? So the measure of angle 1, this exterior angle formed here, is equal to the measure of angle A plus the measure of angle B. Okay? So if you were to draw a circle around 1, the two angles that are opposite of it or not touching it add up to equal it. Okay? Hope that makes sense. We're actually going to do this in an example next, so let's just keep going. So they want us to find the measure of angle DEF. DEF, right here. They want us to find this angle measure. Well, to do that, we're going to have to solve this equation for x. So we know that DEF equals the opposite two angles added together from it. So 80 plus x is going to equal DEF. So let's go ahead and write this down. 3x plus 6 equals 80 plus x. Okay, let's just start solving this. We subtract x from each side of the equation. These x's cancel out. We're left with 2x plus 6 equals 80. Okay, let's subtract 6 from each side of the equation. These 6's cancel out. We're left with 2x equals 74. Okay, divide each side by 2. And x equals 2 goes into 7 3 times, carry the 1. No, sorry, 2 goes into 7 3 times, carry the 1, 17. Okay, x equals 17. I hope I did that math right. Let's go ahead and to find DEF, we just have to plug 17 back into this original equation. So I'm just going to do that right here. 3 times 17 plus 6. 3 times 17. Let's just go ahead and do that math right here. 17 times 3. That's going to be 1. Carry the 2. 3, 51. So 51 plus 6. So our answer should be 57 degrees. Okay? Hope that made sense. That's how we work through it. Let's keep going. So a corollary to the theorem is a statement that can be proved easily using the theorem. The corollary below follows from the triangle sum theorem. Corollary to the triangle sum theorem. The acute angles of a right triangle are complementary. So if you know that a triangle is a right triangle, its two acute angles will add up to equal 90 degrees. So the measure of angle A plus the measure of angle B equals 90. Okay? So the support for the skateboard ramp shown forms a right triangle. The measure of one acute angle in the triangle is 5 times the measure of the other. Find the measure of each acute angle. So we know this is a right triangle, and we know that one of the angles is 5 times the measure of the other. So we know it'll be 5x and x for our angle measures. And we know those two angles have to add up to equal 90 by the theorem we just learned. So 5x plus x has to equal 90. Let's go ahead and write that down. 5x plus x equals 90. Okay, so we combine our x's to be 6x equals 90. Divide each side by 6. And x is going to equal 15. Okay, so we know our x value is 15, but that is not the question. They want to know the measure of each angle. So we have to plug in our x values into each of these angles. Well, plugging it in for x is really easy. We know one of the angles is going to equal 15 degrees. Okay, and the other angle is just 5 times x. Or 5 times, let me just write 15. 5 times 15 is going to equal 75 degrees. So one angle measure is 15 degrees and the other is 75 degrees. Alright guys, that's the whole lesson. That wasn't too bad. I hope you're all doing good. Please keep up the homework, keep studying, keep rocking, and I'll see ya!
Wow.